So to celebrate 100 years of Finnish independence, I would like to share with you something where we are in the top of the world. We are the best in the world. So traditionally, Finland has been a really active nation in putting R&D invests in relation to economy or population. But we have been losing our position here bit by bit, as you see from the horizontal plane. And of course, as a small nation, we are a small player in total R&D investment, as you can see from the size of those circles. But if you take the ratio of scientists and engineers in a population, we are clearly #1 in the world. So congratulations. So I'm not sure how we can, in the best way to make use of this benefit, but maybe it at least gives us a good starting point to improve technology, implement technology, apply technology to new things efficiently. So VTT is an important player in this unholy alliance of scientists and engineers. Our task is to generate positive impacts to Finnish society and economy through technology development. Bioeconomy is a really important field with VTT, with hundreds of experts working directly in this area, so we have many things where we can and we contribute. But to make focus, I concentrate today on some special topics related to forest industry and photonics, namely remote sensing of forests, dimensionality measurements from individual trees with lidars, and if I have time, maybe some machine vision approaches. Okay, Jussi Soukkamäki from Senop already yesterday gave a really nice presentation how to apply Fabry-Perot interferometer-based hyperspectral imaging in classification of trees in forests or mapping tree damage due to pests or diseases. VTT's role here has been and is to develop the basic technology to enable this hyperspectral imaging. So the technology here is the Fabry-Perot interferometer, as explained by Jussi yesterday. It is about having two mirrors in parallel and the gap between them, which you can tune. And by tuning this gap, you can select the wavelength really accurately, which is transmitted through this structure. So you can make spectrometers out of this. This is in essence a tunable optical filter, and real spectroscopic measurement you can put it either between the light source and the target to illuminate the target with well-defined wavelength, or you can put it between the target and the detector and measure the light which comes from the target each wavelength at a time. That formula is for Juha. He's a mathematician in his roots. Okay, so you can make single point spectrometers out of this technology, or you can make hyperspectral images. We use two manufacturing platforms to make these hyperspectral images or spectrometers. For high volume sensor applications, the choice is to use MEMS-based high volume manufacturing methods. For small scale production or medium scale production, the preferable choice is to make a assembly process with decent manufacturing costs. we have quite an extensive patent portfolio for this technology. We have currently 12 patent families for this, and we have licensed this to many companies, including 2 spin-off companies from VTT. So over the years, we have demonstrated this technology in spectrometers for wide set of different wavelengths, all the way from ultraviolet to far IR. If you think of forest mapping through hyperspectral imagers, Xenop already has a nice product for this in visible wavelength regime, so this is not anymore our main development focus area. But we have developed hyperspectral imagers also for short wavelength IR regime and even thermal IR regime. So we are willing to license this technology to anyone who wants to put this technology to commercial use. Important to notice is that it's not only for drones. For example, one hyperspectral imager developed by VTT is currently in space, measuring from satellite as part of the Aalto-1 satellite. But these can be put also to iPhone. We have demonstrated hyperspectral imager from iPhone and any kind of smart machine. So in addition to focus, really focus technology component development like interferometers or detectors, we can also be a partner in sensor or data fusion concepts, regardless of the platform where the sensors are put. Okay, about individual tree mapping, I have noticed from the audience that many of you have really deep understanding of LiDARs, so I will not go through that much. I only say that it's not just one single LiDAR technology. There are several concepts available, and the technology is developing really rapidly, and each of the concepts has the benefits and limitations. So it's important to understand the physics and optics to make smart choices. So we have been also active using LiDARs, both in developing the LiDAR components themselves, but also applying LiDAR technology to new application areas, for example, in bioprocessing and stuff like that. So if you have not seen a point cloud before, how it's produced, I try to open this video. This is a LiDAR time of flight measurements from several trees through foliage, and you can see that the backside of the trunk is not mapped. We have used our own LiDAR setup to do it. So this can be used in smart machines in terrestrial measurement applications. Okay, and then shortly about machine vision concepts. We have been really active in developing automated vehicles and automated machines. VTT's test car was the first passenger car in Finland which was allowed to drive in city traffic. And of course it needs a wide set of sensors. It's clear that both in cars and also smart vehicles, you need to have many different kind of sensors to fully do the job. We have also made some initial pilots about automatically moving machines in forests, and that one is one LiDAR concept which was developed with VTT in the past. So over the years we have developed a really wide set of different optical instruments to many application fields. And in order to do it, you need to master several aspects of instrument development. And for example, in dimensional measurements, there are really large amount of different optical concepts that you can use for machine vision. These are some of the technology approaches that we have used in dimensional measurements. Laser triangulation is a well-known photometric. Stereo is a little bit more exotic. You can use structured illumination to determine the dimensions of the target and so forth. And then there are really special things like confocal imaging, covered stereo deflectometry concepts. And some of these are now commercialized to spin-off companies. Okay, just to finalize what we can offer to you, we can make, based on our technology know-how, expertise, assessments of different technologies that are available and which one of them is best suited for your application. If no commercial solution exists, we can develop the missing pieces. We can design, implement customized systems, and sometimes we improve existing systems which have been bought and installed but are lacking in some aspect of performance. And finally, there's really little that we can do just on our own, so we need partners. So of course we need companies who are willing to go forward in technology and commercialize technology, and then we need R&D partners, and in forest industry, especially those who are really application oriented, like Luke. And I'm sure that we need new kind of value chains, new kind of ecosystems to move forward in this area. So that's it. Thank you.
Thank you very much. So we have time to questions or comments. So there is a lot of different technology what VTT is already developed, and some those are commercialized. But how you can see the cooperation related, especially to smart machine? So do you have something research topic or that kind of cooperation already started?
Yes, so VTT also has research on automation, but I would assume that, and you saw the example of drones and satellites and cars and so on, but I guess we could do more in these machines for forest industry, and I see their potential for partnerships between companies and us to make sensor expertise, then automation expertise, robotics expertise, and then business insight, business development.
So other thing what I came my mind when you established and about the autonomous car, so that you can, it is self-driving. So there is a lot of different type of technologies inside and sensors. So can you point out some sensors which could be used in the smart machine and forest machine?
Yes. First of all, I guess that the dimensional measurements are important, and there are LiDARs developed for car industry already. But we need cheaper LiDARs. We need more better performing LiDARs, more connected LiDARs, and this is the message that we have received from car industry. And we are also quite active in thermal imaging, but and also like not light-based radar, but millimeter-based radar systems and so forth. So it's really a combination that I can answer here.
Any other questions?
Markku Keininen, University of Eastern Finland. I think you mentioned a hyperspectral camera with a spectral range from 900 to 1700 for UAVs. What is it good for if you use it for drones, and do you have an application area already in mind? For example, for vegetation studies or forest sites?
Yeah, maybe it's visible here. Here. So here are listed some examples there on the top which can be used, and to have real chemical information, it might be difficult in visible regime. So near infrared is a good wavelength range to get chemical information to identify materials and maybe even the content of materials. So one example that we have been doing research a lot is pharmaceutical industry. And that there we have made a content map of individual pills, distribution of say this active pharmaceutical ingredients in pills or in the flow process. So the answer is to get better insight for chemical identification and for example chemical imaging. Not happy.
But was it for drones, for UAVs?
Okay,
You're
we
not
have.
going to look at pharmaceutical pills from a drone, I guess.
Well, also in this respect, to have chemical information for trees and forests, for example, from diseases, how to really identify it, whether there is a disease which cannot be seen in visible range, for sure. But we are not the best in molecular, biology and so on. So we need partners for that. But this is a clear message from agriculture, for example, that you need to have IR measurements for chemical identifications of various stuff.